Good evening everyone, good evening. I welcome you all again to JEE Enthuse after so long, right? Yes. Well people, first of all, you'll be letting me know in the chat box if I'm audible and visible to everyone. Let me know in the chat box people if I'm audible and visible to everyone. Hello Haik, hello Rudresh, hi Gayatri, hi Krishna. Hello Manisha, hello Music Stories, hello Priyanka. Hello Rudresh, hi Prasanna. Welcome back people, welcome back. Just let me know in the chat box, give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Yeah? Give me some green signal from the chat box people, give me some green signal. Hello Sanju, hi Shweta, hi Srinidhi, hello Divya. Welcome back everyone. Hello Aditya. Hi Ashita, what's up? Perfect guys, perfect. Just give me a second, we'll be starting, right? Just give me a second. Alright, so people, as you all must be knowing, tonight it's going to be our 17th mock test of your next JEE attempt, right? Which is going to be held in this month itself, right? Okay, it's going to be the 17th mock test. As I promised you earlier, we are going to do some 30 mock tests in total, right? This is going to be our 17th, and apart from this, there'll be 13 more mock tests for your JEE 2021, right? So before starting the session, the ones who are new to the channel, let me introduce myself, people. My name is Wassim Bhatt, and I'm your chemistry master teacher writer on this JEE Enthuse channel, right? The ones who have not liked the video yet, please do like the video. Share the video with your friends and do not forget to subscribe to the channel and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this JEE Enthuse channel, right? So do like the video, share the video with your friends and do not forget to subscribe to the channel as well, right? Yes, Ashita, you can watch it too. You can watch it too. Perfecto guys, perfect. So do like the video, share the video with your friends and do not forget to subscribe to the channel as well, yes? So people, you can let me know first of all in the chat box if you guys are super duper excited about the session, right? As you used to be in the earlier mock tests, right? Let me know fast in the chat box if you people are super duper excited, right? Yes, Akash will be doing that, no issues at all. Let me know fast with some thumbs ups. Yes, the Josh is high it seems, right? That's what I wanted guys, that's wonderful. So let's get going, let's get started with the rank booster JEE 2021 complete chemistry mock test number 17 with the first question, which is going to be on your screen in 3, 2, 1 and now. This is the question on your screen people and you can clearly solve this one as well. X, Y and Z are. Okay, we are given the curve between fraction of molecules versus molecular speeds, right? We are given with 3 curves for gas X, gas Y and gas Z, right? We need to identify these gases first of all, yeah? We need to identify these gases over here from the curves and I'm sure you can clearly solve this one, right? Yes, Acharna, there will be daily mock tests, right? Hello Joy, welcome bro, welcome. Just let me know its answer people in the chat box. What do you think about this? Well, people are saying option C and D. Well, I believe option C must be the answer. Yes, option C must be the answer. And how come option C must be the answer? Let's have a look on this. Have a look properly, guys. Okay. So, well, I think option C must be the answer. First of all, if you remember your noble gases start with helium. Then we have got neon, right? We have got argon. We have got xenon, right? Yes, sorry, we have got krypton, then we have got xenon. Let's not talk about the radon and all, okay? Okay, right? First of all, as you must be knowing, as we move down the group, what happens to the molecular mass? Molecular mass increases as we move down the group, right? Okay. People, do you remember the formula to calculate most probable speed? Right? Most probable speed is calculated by the formula of under root of 2RT divided by M, right? So from this relation, can I simply say most probable speed is inversely proportional to molar mass of the gas, keeping the temperature of the gas fixed, right? Most probable speed is inversely proportional to molar mass of the gas. This is something which we know, correct, from this relation. Now understand. If you look at the first curve, right? This is the peak point of the first curve. That means it represents the maximum fraction of molecules. And the speed possessed by maximum fraction of molecules is what I call as most probable speed. This is basically the most probable speed of gas X, right? This is the most probable speed of gas X. Similarly, this will be the most probable speed of gas Y. And similarly, this is the most probable speed of gas Z over here, right? If you compare these molecular speeds, can I say most probable speed of gas Z is greater than most probable speed of gas Y, is greater than most probable speed of gas X? I'm writing in the same way. Most probable speed of gas Z is maximum, followed by most probable speed of gas Y, followed by most probable speed of gas X, right? We know most probable speed is inversely proportional to molar mass. So more the molar mass, less the most probable speed, right? So I'll say most probable speed of gas Z is maximum, so molar mass of gas Z should be minimum, right? Followed by your Y, followed by your X. This should be the order of the molar masses. This should be the order of the molar masses, right? Okay, so basically your gas X should have the maximum molar mass, followed by gas Y, followed by gas Z, right? We need to identify X, Y, and Z, right? X should have the maximum molar mass. Maximum molar mass is for our krypton. Then Y, that is argon. Then helium. So option C is the one which satisfies our condition, right? The simple question from the chapter states of matter. I'm sure it's clear to everyone, right? This is the question from the states of matter chapter, right, people? Exactly. Okay. Perfecto. So let's move on directly to one more question. I'm sure this is clear to everyone. I'm directly moving on to one more. This is one more question, people. A very, very simple basic question from the chapter Electrochemistry. This is the NTA question, people, right? This is the NTA question. You can clearly solve this one as well. I'm sure you can solve this, right? Let's see exactly how this question is to be solved. Let's see exactly how this question is to be solved. Just a second. Let me just erase this part. Yeah. Okay. As per the question is concerned, a silver cup is plated with silver, right? A silver cup is plated with silver by passing 965 coulombs of electricity. So the charge which is being passed is equal to 965 coulombs, right? 965 coulombs as per the question. The amount of silver deposited. We are supposed to calculate the mass of silver deposited on the silver plate. On the plate, what is the mass of silver that is deposited? That's something which I need to calculate, right? Let's we will see how exactly this question is to be solved. First of all, for the silver to get deposited, there must be a reaction. Which reaction there must be? There must be the reduction reaction, okay? So the reaction that should take place over here is something like this. Ag positive plus 1 electron, it gets converted into Ag solid. This is the reaction which should take place, then only your silver will be getting deposited on the plate, right? Then only your silver will be getting deposited on the plate, right? Now, if I'll ask you, what is the N factor of this silver over here? You will say N factor of this silver is equal to what? Is equal to number of moles of electrons exchanged in the reaction, that's 1, divided by stoichiometry coefficient of silver, that's again 1. The value comes out to be 1, right? So basically, your N factor of silver comes out to be 1 over here, yes? Now, what I'll be doing, I'll be simply writing the mass of silver deposited as per Faraday's first law is basically equal to equivalent mass of silver multiplied by I, multiplied by T, divided by 96500. All of you must be remembering this relation. But people, at the same time, have a look. We are not given the value of current, we are not given the value of time. So instead of this I and T, I'm simply going to write Q, right? I'm simply going to write Q, as simple as that. Perfect. Now, this is something which I'm supposed to calculate, right? Is equal to equivalent mass of silver. Equivalent mass of silver is going to be molar mass of silver divided by N factor of silver, right? In the numerator, we have got Q, and Q value, all of we must be knowing it's 965, right? In the denominator, there is only 96500. The value comes out to be 1.08 grams. So you got to know 1.08 grams of silver got deposited on the plate, which is something which I was supposed to calculate. So option D must be the answer of this question. You can let me know in the chat box if it is clear to every single guy. Yes? Right? Refill, silver shows +1. Right. Well, a lot of red hearts are coming up with the plus signs in the middle. Some doctor is commenting, I guess, yeah? Okay, so let's move on, people. Let's move on to one more question. Yes, I'm sure this is clear to everyone. Moving on to one more question which is on your screen. A very simple question again, right? From the chapter Thermodynamics. Yes? Right? 1 mole of methanol when burnt in oxygen gives out 723 kilojoules per mole of heat. If 1 mole of oxygen is used, what will be the amount of heat evolved? It's a nice question, simple, and the conceptual one, right? I'm sure you can solve this one. I'm sure people you can solve this one. Give it a try. Let me know its answer. Till then, I can have some water. Yeah. Give it a try, people. Give it a try. Surya, you're not late, right? I'm just done with one question. Give it a try, people. Let me know its answer fast. Yeah. Okay. All right. So let's see how exactly this question is to be solved. First of all, I'm starting with the methanol, right? 1 mole of methanol when burnt in oxygen, right? I'm starting with CH3OH. This is something which I call as methanol. I'm making it to react with oxygen when it's burnt, right? Burnt means I'm making it react with oxygen, right? It will always lead to the formation of carbon dioxide and water. It will always lead to the formation of carbon dioxide and water, right? Okay, correct. So let's try to balance the reaction first. This should be 3 by 2 times. This should be 3 by 2 times. And this should be 2 times. I think the reaction is balanced, yeah? I think the reaction is balanced, okay? Now people have a look. When 1 mole of methanol is burnt, how much heat is released? 723 kilojoules of heat is released. I'm writing the same thing over here. When 1 mole of methanol is burnt, how much heat is liberated? 723 kilojoules of heat is liberated, right? As per the question, when we burn 1 mole of methanol, this much amount of heat gets liberated, right? This is something which is given to me as per the question. Now, as per the question itself, if 1 mole of oxygen is used, okay? So first of all, in this reaction, 1 mole of oxygen is being used. 1 mole of oxygen is being used. Understand the logic which I'll be using. See, look at the stoichiometry, guys. Over here, the stoichiometry coefficient is 1. Right here, the stoichiometry coefficient is 3 by 2. Can I say 3 by 2 moles of oxygen reacts with 1 mole of CH3OH, right? I'll say something like this. 3 by 2 moles of oxygen reacts with 1 mole of methanol. Reacts with 1 mole of methanol as per the question. Yes. Okay. So can I say 1 mole of oxygen reacts with 2 by 3 moles of methanol, right? 2 by 3 moles of methanol, correct? Right? So you got to know 3 by 2 moles of oxygen reacts with 1 mole of methanol. So I can say 1 mole of oxygen reacts with 2 by 3 moles of methanol, right? So basically, as per the question, 1 mole of oxygen is used, right? If 1 mole of oxygen is used, that actually means 2 by 3 moles of CH3 are used, CH3OH are used, right? So in this reaction, how many moles of CH3OH are used? As per the question, 1 mole of oxygen is used as per the reaction. So I got to know if 1 mole of oxygen is used, that should clearly imply one thing, that 2 by 3 moles of CH3OH must be used, right? Right? Okay, and we know for the combustion of 1 mole of CH3OH, how much heat is liberated? This much amount of heat is liberated. So for the combustion of 2 by 3 moles of methanol, how much heat will be getting released? 723 multiplied by 2 by 3 kilojoules, right? Solve it out. This much amount of heat will be getting released at the end, right? Okay, solve it, get the answer. 723 multiplied by 2 by 3 is going to be the answer of the equation, right? So when you solve it, you get the answer exactly as 482 kilojoules. So you got to know exactly 482 kilojoules of heat is being liberated as per the equation, right? Perfect. Yes. So how did I solve this? First of all, I got to know how many moles of methanol are being consumed in this reaction. And it was already mentioned, if we do the combustion of 1 mole of methanol, 723 kilojoules of heat will be getting released. I got to know 2 by 3 moles of methanol are being consumed. If 1 mole gets consumed, 723 kilojoules gets liberated. If 2 by 3 gets consumed, so 723 multiplied by 2 by 3 moles of methanol will be getting consumed, right? So this was the question from the chapter Thermodynamics, right? Okay, one more question. In the following reaction, the Z is, okay, this is our substrate. This is our substrate, oh, right? I'm making it to react with the NaBH4, which is the reducing agent. What is going to happen? What is going to happen? What is going to happen over here, people? Can you let me know its answer fast? Can you let me know its answer fast? I really want to see what exactly is going to be the answer. Let me know. Let me know, people. What do you think about this? Exactly, music story. It is the selective reduction, right? Yes, your NaBH4, it does not reduce the ester group, it reduces the carbonyl group, right? Your NaBH4, which is the reducing agent, it does not reduce the ester group, it reduces this carbonyl group, C double bond O, right? So it will be reducing this ketone into the alcohol, right? It will be reducing this ketone into the alcohol, okay? This C double bond O, it will be reducing into C single bond OH, correct? So what is going to be my final product? Final product, instead of this double bond, you'll be putting a single bond. With this oxygen, you'll attach hydrogen, right? Okay, so what is going to be the answer? Which option satisfies it? This is going to be it, right? This is the answer. OH over here, right? Rest, there'll be no change. Rest, there'll be no change. Simply, this NaBH4, it's going to reduce this this keto group over here. It's going to do nothing with this ester group. It's going to reduce this C double bond O into what? Into COH, correct? Yes, this is again the question which is given in your NCERT, right? Let's move on to one more question. So option D is the one which is correct among all. So remember, NaBH4 is a reducing agent, but it only reduces the carbonyl group, not the ester group, right? Moving on to one more question, people. I'm given the reaction, right? 2 times N2O5 gives 4 times NO2 plus O2. The rate and the rate constant are this and this respectively. The concentration of N2O5 is something which I'm supposed to calculate, right? Yes. Let's give it a try. Let's see exactly how this question is to be solved. Understand properly, people. It's a simple question from the chapter, Chemical Kinetics, right? See, let me write the reaction first. It's 2 times N2O5 gives what? It gives 4 times NO2, and at the same time you get oxygen as well, right? This is the reaction which is taking place. Now, first of all, it's not mentioned in the question whether the reaction is of the order 0 or of the order 1. But if you look at one thing, this is the rate constant. This is the rate constant. Its units are second inverse, right? When the rate constant has the units second inverse, that means this reaction is of the order 1. It is the first order reaction, I got to know. By just looking at the units, it is the first order reaction. Now, people, if it is the first order reaction, can you write the rate law of it? Rate of the reaction is equal to rate constant of the reaction multiplied by concentration of reactant raised to the power of the order, and order of the reaction is 1, right? As simple as that. Yes. What am I supposed to calculate? I'm supposed to calculate concentration of N2O5 as per the equation, which is going to be rate of the reaction divided by rate constant of the reaction. What is the rate of the reaction given to me? Rate of the reaction is given to me as 1.02 into 10 raised power minus 4, 1.02 into 10 raised power minus 4. What is the rate constant of the reaction? It is 3.4 into 10 raised to the power minus 5. Yes. So what is going to be the answer of the equation? You can solve it, right? You can just divide these two, get the value of your what? Get the value of concentration of N2O5, and let me show you exactly what is going to be the answer of the equation. The answer of the equation is going to be 3 molar exactly, right? Perfect. Just give me some good. Basically, Ritu ma'am, I think she's busy with some stuff. I have no idea, right? I'll talk to her tomorrow. I'll let you know when she's going to join back on NEET Elite channel for your zoology, right? I'll talk to her tomorrow. Tomorrow I'm going to talk to her, and I'll let you know about like when she'll be taking the rest of the sessions. Raghu, nurture series will be resuming, right, from the coming week, right? This week we already took a session, correct, from the coming week. Maybe on Tuesday or Thursday we'll be having the nurture series as well, right? Perfect. Let's move on, people, to one more question. This is one more question. Again, a very simple and the selective question, right? Yes, this question was asked in JEE Main's July attempt, right? Rajaraman will be doing the Pathfinder as well. I'm really sorry, bro. I could not do that this week. Okay, next week I'm going to do that, right? Okay, let me know the answer of this question, people. We have got something as P. I'm making it to react with CHCl3 in presence of KOH. People, do you remember the reaction in which we make something to react with CHCl3 in presence of KOH? Right? Do you remember the reaction? In which you get the poisonous product. Which is the poisonous product? That is the isonitrile, if you remember. Right? And which reaction it's going to be? It's absolutely going to be the carbolamine test. And in the carbolamine test, in the carbolamine reaction, what do we take as the substrate? In the carbolamine reaction, we take the primary amine as the substrate, right? So P must be your primary amine, right? And Q must be your isocyanide, right? Isonitrile, right? Yes. So which option satisfies it? Very simple. P is going to be your primary amine, right? P is going to be primary amine, and Q is going to be isonitrile. So option C must be the answer of this question. I'm sure it's clear to every single guy. Yes? Perfect. Okay. Dave, I'll be doing that. As per the analysis of July attempt, can we score 60 plus in chemistry from NCERT, excluding physical chemistry from NCERT? 60 plus in NC from, I mean, you're asking, can you score 60 plus in your JEE Mains if you're leaving physical chemistry just from NCERT? No, that's not possible, bro. That's not possible. Okay, let's move on to one more question, guys. This is one more question. What is the ratio of the nodal planes of pi star 2p and sigma star 1s? Pi star 2p and sigma star 1s. What do you think about this? Pi star 2p and sigma star 1s. What do you think? First of all, let me show you exactly how this pi star 2p gets formed. Okay. First of all, pi star, that means it's anti-bonding. It's anti-bonding, and anti-bonding molecular orbitals are formed by the destructive interference. Pi star 2p, right? See exactly how this pi star 2p is getting formed. See, guys. This is first of all your one of the p orbital. This is one of the p orbital, right? Let's give them the sign positive, negative. Let's give this as negative, positive, right? This is the nucleus over here. This is the nucleus over here, right? Since I've given the opposite signs on the same side, so it simply says, these are not the charges first of all, right? It simply says there will be the destructive interference, right? And due to the destructive interference, what happens basically? What happens? The electron density between the nucleus gets decreased, okay? So what do we get over here as our molecular orbital? It's going to be the anti-bonding molecular orbital because it is the case of destructive interference, right? So how do I represent it? See, one of the lobe of this p will shift in this way. One of the lobe of the p will shift in this way. One of the lobe of p will shift in this way. One of the lobe of p will shift in this way. This will be your nucleus. This is the nucleus, right? Okay, this is having the positive sign. This is having the negative sign. This is having the negative sign. This is having the positive sign, right? Now, people, as you all can see right here, how many nodal planes I got. This is the first nodal plane I got, right? This is the first nodal plane I got. This is one more nodal plane I got, right? Nodal plane is the one at which the electron density will be 0. The plane on which the probability of finding the electron is 0. That's something which I call as nodal plane over here, right? And which orbital, which molecular orbital this is? This is your anti-bonding molecular orbital, and this anti-bonding molecular orbital got formed by the parallel overlapping, so it's going to be pi star represents anti-bonding, and it's going to be 2p. So in case of your pi star 2p, you have got 2 nodal planes, right? You have got 2 nodal planes, correct? Now, next case, that is sigma star 1s. See, over here we got to know there are 2 nodal planes, right? There are 2 nodal planes. Now, let's see exactly how many nodal planes are there in sigma star 1s. Let's see, guys. Let's see exactly, okay? See, guys, this is, for example, 1s orbital, right? This is 1s orbital, okay? This is, again, 1s. This, again, 1s. This is the nucleus. You already know this is the nucleus, right? Okay, this is 1s. This is 1s, correct? 1s and 1s. Are they ever going to show parallel overlapping? No, they always show the axial overlapping, and axial overlapping always leads to the formation of sigma bonds. So first of all, sigma molecular orbital will get formed over here, right? Now, depending on whether the constructive interference will happen or destructive interference will happen, right? See, guys, since I need to show the sigma star, that means sigma star is anti-bonding molecular orbital, and anti-bonding molecular orbitals are formed by the destructive interference, right? Let's give it a positive sign. Let's give this side a negative one. Let's give this one a positive. Let's give this a negative, right? So opposite signs on the same side. Opposite signs on the same side. It shows that destructive interference is going to happen, right? And what is going to happen in the destructive interference? The electron density between the nuclei of these orbitals will be getting will get decreased, right? Okay. So what do I get over here? See, guys. Finally, you get something like this. Electron density between the nucleus got decreased, right? Electron density between the nucleus got decreased, correct? Yes, this is basically the sigma molecular orbital. It got formed by destructive interference, so anti-bonding, so sigma star, and this is 1s, right? Basically, whatever electron density was on this side, that electron density shifted towards this side, right? And whatever electron density was on this side, that shifted on the other side. Because in case of destructive interference, the electron density between the nuclei of the orbitals, that gets decreased, that gets drifted apart. That's why I increase the size of this part of the lobe, and over here in the middle, you got something called as nodal plane, wherein there'll be no electron density at all. So how many nodal planes you got in this case? You got 1 nodal plane, right? So 2 nodal planes here, 1 nodal plane here. What is going to be the ratio? Ratio is going to be 2:1, right? 2:1 is going to be the ratio over here of the nodal planes. I'm sure it's clear to everyone. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yes. If it is bonding molecule orbital, then there'll be no nodal plane in case of sigma 1s. In sigma 1s, there is no nodal plane as such. This is how your sigma 1s looks like. This is how your sigma 1s looks like, right? There is no nodal plane. Electron density between the nucleus will be maximum, right? This is sigma 1s, no nodal plane. Nodal plane is 0. You won't be finding any plane over here in case of sigma 1s molecular orbital wherein the electron density will be 0, right? Yes? Perfect. For your inorganic chemistry, NCERT is the best. Just read the NCERT, mug up the NCERT, right? Read every single line of NCERT, guys. That is the best solution for your inorganic chemistry, right? Yes, Gayatri will be doing the top-notch questions from GOC as well, no issues. All right, one more question, people. A very, very simple question from the chapter Ionic Equilibrium. And this question was asked. Okay, this question was not asked anywhere. This is simply mock test question, right? Okay, this is the mock test JEE 2021, right? Okay, this is the NTA question, people, right? Let's try to solve this one over here as well. So pH of the saturated solution of CaOH whole twice. So basically we have got a saturated solution of CaOH whole twice. So it's going to dissociate. How come? How come it's going to dissociate? It will remain in equilibrium with its ions, and its ions are Ca di positive aqueous plus what? Plus 2 times OH negative aqueous, right? This is how it would have got dissociated, right? First of all, let's assume the solubility of this solution is S. So concentration of Ca di positive is going to be S. Concentration of OH negative is going to be 2S, right? Concentration of OH negative is going to be 2S, correct? I got the concentration of Ca di positive, I got the concentration of OH negative, right? Now people, it's mentioned in the question that pH of the saturated solution is 9, okay? Well, pH of the saturated solution of CaOH whole twice is 9. We know pH plus pOH at 25 degrees centigrade, all of you must be knowing that's 14. If pH is equal to 9, that simply means pOH will be equal to 14 minus 9, that is 5. If pOH is equal to 5, that simply means OH negative concentration is equal to 10 raised power minus 5, right? You got to know OH negative concentration is 10 power minus 5. But people, OH negative concentration is equal to 2S. So you got to know 2S is equal to what? 2S is equal to 10 raised power minus 5, which clearly says S is equal to 10 raised power minus 5 divided by 2, right? Now write the expression for KSP and get the answer. So KSP of this saturated solution of your CaOH whole twice is going to be concentration of Ca di positive, that's S, right? Which is basically 10 raised power minus 5 divided by 2. So it's going to be S raised power 1 stoichiometric coefficient multiplied by 2S raised power 2. What is the value of 2S? Value of 2S is 10 raised power minus 5. So this 10 raised power minus 5 raised power its stoichiometric coefficient, that's 2 over here. Now it's your turn to solve it further, get the value of KSP, that's it, right? Isn't the question very simple, people? Isn't the question very simple? Yes? Prasanna, I prefer to read GOC from the Solomon file. There's a book called the Solomon file. I prefer to go through it for the GOC questions, right? Okay, let's move on, people. So you get the answer as 1 over here, right? Let's move on to one more question, right? So basically, this is my substrate. I'm making it to react with NaNO2 HCl, right? 0 to 5 degrees centigrade. I'm getting some product D, right? And D, in presence of your CuCN, KCN, you get something as E plus N2. Again, a very, very simple question. Again, a very, very simple question. And I'm sure you can easily kill this one, right? What is going to be the answer of this question, people? It's a very simpler one. First of all, what is going to happen? In presence of NaNO2 HCl, diazotization will happen, right? Diazotization will happen. Okay, so what do you get? This D over here, D is what I call as diazonium chloride over here. So it's going to be like this. This is, instead of your NH2, you'll be simply writing N2Cl, right? And this is your CH3 as such. Now, in presence of your CuCN, KCN, what do I get? Simply what you'll be doing over here is just replace this N2Cl, instead of this N2Cl, put Cn over here. So final product is going to be what? Final product is going to be like this. This is Cn at the top, and already there was CH3 in the bottom, right? So this is my final product, which I call as E. Yes, which I call as E, right? Which option satisfies it, people? It's going to be option C, which exactly satisfies it, right? Yes, I'm sure it's clear to everyone. Let's move on directly to one more question. I think this is clear to everyone, right? Moving on to one more question, guys. Identify the correct hybridization of NO2 negative, NO2 positive, NH4 positive. People, let me know the answer of this question. I'm not going to do it. Let me know. You guys are going to let me know the answer of this question, right? Let me know fast. Let me know fast. No, Joy, there is no formula as such. Well, I've taken the session for molecular orbital theory on NEET Lead channel. You can check it out. You'll definitely love it. See guys, let's get going. Let's see exactly the hybridization in each of the cases. First of all, NO2 negative. NO2 negative. How many sigma bonds? 2 sigma bonds, right? How many lone pairs on nitrogen? There is 1 lone pair on nitrogen. Steric number, sigma bonds plus lone pairs. Sigma bonds plus lone pairs. Steric number is 3. Steric number is 3. That clearly says hybridization is going to be sp2. As simple as that, okay? If you talk about NO2 positive, in case of NO2 positive, how many sigma bonds? 2 sigma bonds. How many lone pairs on nitrogen? 0 lone pair. Sigma plus lone pair, 2 plus 0. Steric number is 2. If the steric number is 2, hybridization is going to be sp, right? In case of NH4 positive, how many sigma bonds? 4 sigma bonds. How many lone pairs on nitrogen? 0 lone pair. What is the steric number? 4 plus 0, that's 4. What is the hybridization? It's sp3, right? The question is done and dusted. sp2, sp and sp3. sp2, sp and sp3. Option A is the one which is correct among all, right? Perfect. Do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, people. This was a very simple question which is done and dusted. Moving on to one more, right? It's a basic question, guys. And see, this question was asked in JEE Main's July 2019 attempt, right? See what kind of question was asked. Now from this question, you would get the level of your JEE Mains nowadays, right? See, the question from the solid state, correct? The number of atoms present in simple cubic unit cell, body centered, face centered. SCC, BCC and FCC, right? In case of SCC, how many effective number of particles are there? 1. In case of BCC, how many effective number of particles are there? 2. And in case of FCC, how many effective number of particles are there? That's 4, right? 1 to 4, correct? Yes, there is no need to solve this. Or if you want to solve it as well, you can do that. It won't take me more than 1 minute. See, in case of SCC, the constituent particles are present only at the corners of cube. The contribution of corner is 1/8. Total there are 8 corners, 8 corner particles, so the value comes out to be 1, right? In case of BCC, the constituent particles are present at the corners and at the body center. The contribution of corner is 1/8. Total there are 8 corner particles, right? There is 1 particle at the center whose contribution is 1 multiplied by only 1 particle. The value comes out to be 2, right? In case of FCC, the constant of the corner particle is 1/8. Total there are 8 corner particles. There are face-centered particles as well. The contribution of the face-centered particle is 1/2. Total there are 6. The value comes out to be 4. So 1 to 4 comes out of the answer, right? Yes. Perfecto. Let's move on to one more question, guys. It's a very simple one, I must say, right? Okay, this is a nice question. This is a nice question from the chapter Thermodynamics, right? Let's exactly see how this question is to be solved. See guys, we have got the sample of fluorocarbon. It is allowed to expand reversibly and adiabatically. We have got the sample of fluorocarbon in the container. It's allowed to expand reversibly and adiabatically, right? So we are basically talking about reversible adiabatic expansion. We are basically talking about reversible adiabatic expansion. I'm doing the expansion of the fluorocarbon reversibly and adiabatically, right? Okay, was allowed to expand reversibly and adiabatically to twice of its volume. Let's say initial volume of the gas was V, so final volume of the gas as per the equation is going to be 2 times V, right? I'm doing the expansion of the gas, right? Unless I'm doing the expansion of the gas, unless the volume of the gas doubles, right? In the expansion, the temperature dropped from 400 Kelvin to 100 Kelvin. So initial temperature of the gas is 400 Kelvin and the final temperature of the gas is 100 Kelvin, right? Is 100 Kelvin, correct? Assuming the ideal gas conditions, calculate the CV for the gas. We are supposed to calculate molar heat capacity at constant volume. We are supposed to calculate CV for the gas, right? CV is something which we are supposed to calculate. Well, people, I hope you know the formula to calculate CV. CV is equal to R divided by gamma minus 1, right? That simply means I need to calculate gamma. If I got the gamma, I got the CV because CV value is given in terms of R, right? Now, how to calculate this CV value? It's the reversible adiabatic process. And for the reversible adiabatic process, I can use the equation T1 V1 raised power gamma minus 1 is equal to T2 V2 raised power gamma minus 1, right? What is T1? T1 is 100. What is V1? V1 is V raised power gamma minus 1. What is T2? T2 is 100. What is V2? That's 2 times V raised power gamma minus 1. So first of all, V raised power gamma minus 1, V raised power gamma minus 1 gets cancelled. So this 0, 0, 0 got cancelled. So 4 is equal to 2 raised power gamma minus 1. 4 is equal to 2 raised power gamma minus 1, right? As simple as that. So this 4 I can write as 2 square. So 2 square is equal to 2 raised power gamma minus 1. That clearly says gamma minus 1 is equal to 2, which clearly says gamma is equal to plus 1, 3, right? Gamma is equal to 2 plus 1, 3. So R divided by gamma is 3, 3 minus 1 is 2. So R divided by 2 is going to be the CV value for the gas. So option 2 is the one which is the correct answer of this question, right? Yes? Perfecto? Absolutely, guys. Wonderful. Let's try to move on to the next question then. I'm sure this is clear, right? Okay, during the change of O2 to O2 negative, right? The electron ends on in which of the following orbitals, right? Okay. If you remember the molecular orbital configuration of O2, there are two unpaired electrons in the last two anti-bonding molecular orbitals, right? Okay. So from O2 to O2 negative, that means I'm giving one electron, one extra electron to O2, right? From O2 to O2 negative, that means I'm giving one extra electron to O2. That one extra electron goes into, yes, that goes into pi star 2px, right? Pi star 2px, correct? See, this is the outermost molecular orbital configuration for O2. One electron in pi star 2px, one electron in pi star 2py. Now you are giving one more electron, so that one more electron will enter into this one, into this anti-bonding molecular orbital, right? Yes? Perfect? Exactly. Hike is asking for molecular orbital theory. Bro, I have taught molecular orbital theory already on NEET channel, right? You can search on YouTube molecular orbital theory by Wassim sir, you'll get it, right? Okay, that too in detail. Perfect? All right, then electrons identified by the quantum numbers n and l, right? Okay, what do I need to calculate? These can be placed in the increasing order of the energies, right? I need to arrange the orbitals on the basis of increasing order of energies, and for each orbital, I'm given with the value of n and l. How do we do that? How do we do that, right? How do we do that? See, there is a simple rule called as n plus l rule, or you call as Bohr-Bury's rule, right? By means of which you arrange the orbitals on the basis of their energies. More the value of n plus l, more is going to be the energy of that orbital, right? More the value of n plus l, more is going to be the energy of that orbital, right? Yes? If for two orbitals n plus l value is same, then that orbital which will be having lesser value of n will be having lesser energy, as simple as that, right? The question is almost done. See guys, understand now. First thing, in the first case, what is the value of n plus l? 4 plus 1 comes out to be 5. So n plus l value is 5 in this case. 4 plus 0 comes out to be 4. N plus l is 4. N plus l, 3 plus 2, 5, right? N plus l is 5. N plus l, 3 plus 1, 4, right? So first of all, the energy of second and fourth is going to be less than that of energy of 1 and 3, right? Now, first thing, this is having n plus l4, this having n plus l4, which is having lesser value of n among the two. Lesser value of n among the two is for this one. So 4 is going to have minimum energy. 4 is going to have minimum energy, followed by 2, right? Now, among 3 and 2, both are having same n plus l value. Look at the n value now. N value is 3 over here. N value is 3. So 3 is going to have lesser energy compared to 1. Look at this order. Just see, is this matching with any of the order 4, 2, 3, 1? Option 2 is the one which is going to be correct among all, right? Yes, people? Raghu, I won't be able to do that, bro. I cannot take 3 sessions for the class 11th. No. I can take 2 sessions for class 11th per week, right? 3 sessions is impossible for me because I'm currently handling 2-3 channels on YouTube, right? NEET Elite channel, this channel, and sometimes Catalyst as well, right? Apart from that, long-term batches as well. Yes, on the actual Vedantu platform, right? There are a lot of things going on, so I won't get time for that. Yes, I hope you get it. Perfect. Moving on to one more, guys. This is one more question. 1.12 grams of calcium oxide is reacted with the excess of HCl and 1.776 grams of CaCl2 is formed. What is the percentage yield of the reaction? First of all, you should remember the formula to calculate percentage yield. See guys, the formula to calculate percentage yield is always equal to experimental amount divided by expected amount multiplied by 100. This is the formula by means of which we can calculate the percentage yield of the reaction, right? Now the point is, how do we do it? How do we calculate the experimental amount? How do we get the expected amount? Experimental amount is always given to us as per the question, right? See, as per the question itself, it's mentioned when I'll make 1.12 grams of calcium oxide to react with HCl, it will lead to the formation of 1.776 grams of CaCl2. So this is something which has been observed, which has been checked in the laboratory basically, right? This is something which has been observed experimentally, that when we do the reaction of 1.12 grams of calcium oxide with the HCl, we will be getting this much amount of CaCl2, right? This is something which is checked experimentally. So experimental amount is given to us. Now what about the expected amount? Expected amount of CaCl2 I'll be calculating. Expected amount of CaCl2 I'll be calculating by means of stoichiometry, right? Yes, right? And how do we get the expected amount by means of stoichiometry? Check it out properly. See guys, this is a balanced chemical equation, right? If I'll ask you, what is the mass of 1 mole of calcium oxide? That means I'm talking about the molar mass of calcium oxide. And molar mass of calcium oxide is 56 grams, right? 56 grams is the molar mass of calcium oxide, or you can say 56 grams is the mass of 1 mole of calcium oxide. If I'll ask you, what is the mass of 1 mole of CaCl2? Mass of 1 mole of CaCl2 means molar mass of CaCl2. Molar mass of CaCl2 is 111 grams, right? Yes. So I got to know from the stoichiometry of the reaction, 56 grams of calcium oxide gives 111 grams of CaCl2. As per the stoichiometry, 56 grams of calcium oxide, it should give me how much? It should give these many grams of CaCl2. So 1 gram of CaO should give 111 divided by 56 grams of CaCl2, right? So 1.12 grams of CaO should give 111 divided by 56 multiplied by 1.12, and the value will approximately come out to be 2.2 grams of CaCl2, right? So this is something which I was expecting. This is something which I was expecting, right? I was expecting this much amount of CaCl2 to get formed. But is actually getting this much amount of CaCl2 formed? No, right? How much amount of CaCl2 is actually getting formed? Only 1.776. How much I was expecting? I was expecting this much. I was expecting this much, right? So this is something which is my expected amount of CaCl2. Already I have experimental. Experimental divided by expected multiplied by 100. Question is done, right? So it's going to be 1.776 divided by 2.2 multiplied by 100. Check it out. The value will be approximately around 80. Okay, I think the value will be approximately around 80. So option B is the one which is correct among all. I'm sure this is clear to everyone, right? Yes, Monica, next week I'll be doing that. Okay, consider the reaction below and identify RCN. I'm making it to react with diable H when presence of water. What do we get over here? People, again the question directly taken from your NCERT, and I'm sure you can solve this. And this question was asked in JEE Main July 2021, right? What do you think about this one? Absolutely, people, your RCN in presence of diable H, it gets converted into aldehyde, right? It gets converted into RCHO, correct? Yes. RCN gets converted into RCHO in presence of what? In presence of diable H, correct? The question directly from your NTA, right? Yes? Perfecto. Moving on to one more, guys. For the reaction N2 plus 3 times H2 gives 2 times NH3, the partial pressure of N2 and H2 are this much and this much at equilibrium. The total pressure of the system is 2.8. Calculate Kp for the reaction. Okay. See guys, how this sort of equation is to be solved. Understand properly. It's very, very common question, guys, nowadays. N2 gas, I'm making it to react with 3 times H2 gas. It leads to the formation of what? It leads to the formation of 2 times NH3 gas, right? Yes. Now people, it's mentioned in the question at equilibrium. At equilibrium, the partial pressure of N2 is 0.8 atm. The partial pressure of H2 is 0.4 atm, right? Yes. And the total pressure of the system at equilibrium, it's also mentioned, the total pressure of the system at equilibrium is equal to how much? Is equal to 2.8 atm, correct? Now people, the first thing, at equilibrium, there will be some moles of N2 in the container, there will be some moles of H2 in the container, there will be some moles of NH3 in the container, right? Okay, so all these three gases will contribute towards the total pressure of the container at equilibrium, right? All these three gases will contribute towards the total pressure of the system at equilibrium. That means whatever will be the total pressure of the system at equilibrium, that will be due to N2, that will be due to H2, that will be due to NH3, because all the three gases are present at equilibrium in the container, right? Yes. If all the three gases are present at equilibrium in the container, so as per Dalton's law, the total pressure of the mixture at equilibrium will be the sum of their partial pressures. partial pressure of N2 at equilibrium plus partial pressure of H2 at equilibrium plus partial pressure of NH3 at equilibrium. As simple as that. This thing is given to me as per the equation. The total pressure, that's 2.8, is equal. Partial pressure of N2 is given to me as per the equation as well. That's 0.8. Partial pressure of H2 is given to me as per the equation, 0.4. From here, I'll be calculating the partial pressure of NH3, which comes out to be how much? Partial pressure of NH3 comes out to be how much? 1.6 atm, right? I got the partial pressure of each gas. I got the partial pressure of each gas, right? Okay, now it's time to write the Kp expression. How do we write the Kp expression, people? Again, simple. Kp is going to be equal partial pressure of NH3 at equilibrium raised par stoichiometry coefficient, that's 2, divided by partial pressure of N2 at equilibrium raised par stoichiometry coefficient, that's 1, multiplied by partial pressure of H2 at equilibrium raised par stoichiometry coefficient, that's 3. See, partial pressure of NH3 is given to us, right? I got to know partial pressure of NH3 1.6. So this term is given. Partial pressure of N2, it's given 0.8. Partial pressure of H2, this also given. Just put the values, get the answer, and I believe you get the value over here as 50, right? Yes, again, a very simple question, people, right? And if I'll ask you what are going to be the units of Kp, units of Kp generally are atm raised to the power delta Ng. Okay, units of Kp over here will be atm raised by delta Ng. What is the delta Ng for this reaction? Number of moles of gaseous products minus number of moles of gaseous reactants. So 2 minus 3 plus 1, 4. 2 minus 4 comes out to be minus 2. So it's going to be 50 atm raised by minus 2. 50 atm raised by minus 2 is the value of Kp, right? Yes, perfect. Yes, sir, this series will continue till the last paper of your JEE Mains of this year, right? Okay, moving on to one more, people. Which of the following is the most reactive? This one you can solve on your own, right? This one you can solve on your own. I'm not going to solve this. You know it, right? You know it. Which among the following is the most reactive? Cl2, Br2, I2, ICl, right? Give it a try. Give it a try, people. Exactly, your interhalogens. See, if you look at all the options, there is only one interhalogen, which is ICl, okay? Interhalogens are generally more reactive than that of normal halogens due to the electronegativity difference, which makes the bond between iodine and chlorine polar. And if there is a polar bond, that means more reactive. Yes, right? Interhalogen compounds generally, remember, interhalogen compounds are basically more reactive than that of normal halogens, but due to the electronegativity difference between these two halogens, which makes the bond polar. And if the bond is polar, that absolutely means it's going to be less. It's going to be more reactive. Yes. So option D is the one which answer of the question. I'm sure it's clear. Yeah. Calculate the radius ratio of second orbit of He positive and the third orbit of Be positive. Right, guys? Very, very simple question. Again, first of all, you all must be knowing radius of the nth Bohr's orbit is equal to R naught n square divided by Z. Generally, right? Okay. And the units are in angstroms. Okay. Now, people, this is the relation which you all must be knowing. R1 divided by R2 is equal to N1 square divided by N2 square multiplied by what? Multiplied by Z1, and over here this is Z2, right? You must be knowing this relation, right? You must be knowing this relation. Yes? Correct? Now every single thing is given to you, right? Every single thing is given to you. Put the values, get the answer. That's it, right? Put the values, get the answer. That's it. Okay? So see, guys, first of all, I'm given with the second orbit of He positive. For He positive, for helium, atomic number is 2, right? N value for helium is 2. Let's represent helium by 1. So N1 is 2 and Z1 is 2. So N1 is 2, so it becomes 2 ka square, right? 4 multiplied by Z2. Z2 means atomic number of B, hydrogen, helium, lithium, beryllium, atomic number of beryllium is 4, right? Divided by N2 square. N2 means the orbit of B tripositive, that's third. So 3 ka square is 9 multiplied by Z1. Z1 is the atomic number of He over here, that's 2, right? So the value comes out to be how much? 2, 1, 2, 2. It's going to be 8:9. Is there any option as 8:9? 8:9 is going to be the radius ratio. Very simple and formula based question, right? I'm sure it's again clear to you. Perfect. Okay, moving on to one more, guys. The product formed in the following reaction. Okay, this is my amide. I'm doing its reduction by using lithium aluminum hydride in presence of water, right? What do I get as the product? Again, a very, very simple question. Your amide in presence of LiAlH4, it gets converted into the primary amine, right? It gets converted into the primary amine. Yes. So your RCONH2 in presence of LiAlH4, it gets converted into what? RCH2N2, right? instead of CO, I'll be simply writing CH2. Instead of CO, I'll be writing CH2. It becomes RCH2NH2, right? Yes, in presence of what? Lithium aluminum hydride. Yes? Okay. So finally, you get the product as the 1 degree amine over here. Yes? Right? It's going to be RCH2NH2. I'm sure it's clear to everyone. It's option B, people. Moving on, one more. 4 grams of NaOH and Na2CO3 is equimolar. Okay. If it contains X grams of NaOH and Y grams of Na2CO3, then the value of X is, again, a very simple question, right? See guys, just replace this X grams and Y grams, right? Basically, I'm supposed to calculate mass of NaOH and mass of Na2CO3 in the mixture. See how to solve this. I'm giving you the simple way of solving this. See guys. First of all, I've got a container, for example, and this container contains NaOH, and with this NaOH, we have got Na2CO3 as well, right? Okay. What is the mass of the mixture? Mass of the mixture is 4 grams. The mass of the whole mixture is 4 grams, right? Let's assume out of 4 grams, there are X grams of NaOH. That means there will be 4 minus X grams of Na2CO3 in the container, right? Absolutely, yes. Let's assume there are some X grams of NaOH. That means there will be some 4 minus X grams of Na2CO3 in the container, absolutely. Now it's mentioned that it is the equimolar mixture. Equimolar mixture means number of moles of NaOH in the container will be equal to number of moles of Na2CO3 in the container, right? Number of moles of NaOH is equal to mass of NaOH divided by molar mass of NaOH. That's equal to number of moles of Na2CO3. That means mass of Na2CO3 divided by molar mass of Na2CO3. That's 106. People, can you solve this equation, get the value of X, right? And what is that X? What is that X? X is basically the mass of NaOH in the mixture, which I was supposed to calculate. Once you get X, you can clearly get 4 minus X as well, and 4 minus X is the mass of Na2CO3 in the mixture, which is something I was supposed to calculate. As simple as that, right? Aditya, this is JEE Mains mock test, bro, and this question was asked in JEE Mains 2021 20th July evening shift, right? Okay, that's why I'm getting these sort of questions, because this is currently the level of your JEE Mains in chemistry, right? There is no need to solve the difficult questions nowadays for the mains. If you're preparing for advanced, then after the last shift of JEE, which is there on 25th, 26th, something like that, right? After that, we are starting a series for JEE Advanced. You can watch that, right? Or already we have taken one series, that is Killer 5 series. You can check it out in the playlist, wherein that series was completely dedicated to JEE Advanced students. You can check that out as well, right? Perfect. So people, the answer of this question comes out to be, right? Something answer as 1 something. Value of X is, that means you were supposed to calculate the mass of NaOH, right? Mass of NaOH comes out to be 1 gram approximately, yeah? Perfect. Let's move on to one more. Okay, this is one more question, guys. What is the magnetic moment of the complex COCN4 negative? COCN4 negative, right? So over here, cobalt is in +2 oxygen state, as you all can see right here. Yes? Now people, have a look. What is the outermost configuration of cobalt? Iron cobalt, 3d74s2. 3d74s2, right? But this is cobalt di positive, it becomes 3d74s0. There are seven electrons in 3d, right? Cn is a strong field ligand. What is going to happen? Pairing of electrons will happen. After the pairing, how many electrons will be unpaired? After the pairing, there will be 1 electron unpaired. If there is 1 electron unpaired after the pairing, then the spin magnetic moment, which I was supposed to calculate, is going to be under root of n into n plus 2 Bohr magnetrons, right? So it's going to be under root of 1 multiplied by 1 plus 2. So it becomes root of 3. Root of 3 is around 1.73 Bohr magnetrons, right? But what you are supposed to calculate? Report your answer to the nearest integer. The nearest integer is going to be 2 for this 1.73. So 2 is going to be the answer of the question, right? Yes, clear to everyone? Absolutely, Shivam. This will be helpful for KVPA as well. And for the KVPA, we'll start a crash course on the actual Vedantu platform, right? There's a link in the description box of the video. You can click on that link, right? You can get enrolled yourself into the KVPY crash course S6, right? Okay, link is there in the description. The crash course price is somewhat 4K something, right? You need to use the coupon code as something WS, that's given in the description box of the video, right? Perfect. Let's move on to one more, guys. Let's see if we have more questions. Yes, we have got one more question. The efficiency of packing in case of metal crystal for FCC cubic unit cell. In case of face-centered cubic unit cell, what is the percent packing efficiency? What is the packing efficiency in case of FCC, guys? What is the packing efficiency in case of FCC? Do you remember? Right? We have done it many a times. If you do not remember, people, I have taken Few days back only I have taken a session on solid state, complete solid state in one shot, in which I have discussed all these questions, right? People, if you remember, I have told you for SCC, what is the packing efficiency? It is 52.4%. In case of BCC, what is the packing efficiency? In case of BCC, the packing efficiency is 68%. In case of FCC, the packing efficiency is 74%. In case of hexagonal unit cell, right, the packing efficiency is again 74%, right? These are the packing efficiencies in case of different unit cells in your solid state, right? Yes, what you're supposed to check? Packing efficiency in case of FCC, it's going to be 74, absolutely, right? Okay, this is one more question, guys. Find the number of molecules having 2 lone pairs on the central atom. 2 lone pairs on the central atom, right? Again, a simple question. Again, a simple question. Can you let me know fast? Can you let me know fast what should be the answer of this question? I want to hear it from you. People, I want to hear it from you. What is going to be the answer of this question? NTA question this is. Let's check it out. Let's check it out. In case of I3 positive, in case of I3 positive, let's make it I3 negative, guys, okay? Let's make it I3 negative. In case of I3 negative, in case of I3 negative, how many lone pairs are there on central iodine? How many lone pairs are there on central iodine? If you remember your I3 negative sp3d hybridization, 3 lone pairs and 2 bond pairs, 3 lone pairs, 2 sigma bonds. So there are 3 lone pairs basically on the central atom, right? On the central iodine, correct? Right? XEF2, there are 2 sigma bonds. There are 2 sigma bonds, and how many lone pairs will be there? How many lone pairs will be there, guys? In case of XEF2, how many lone pairs? Fast. How many lone pairs on xenon? Exactly, 3 lone pairs, right? 3 lone pairs. This xenon, in case of XCF4, 4 sigma bonds, 2 lone pairs on xenon, right? In case of water, how many lone pairs on oxygen? 2 lone pairs, right? In case of NH2 negative, how many lone pairs on nitrogen? Let me know fast. 2 lone pairs on nitrogen, right? In case of H2SC, how many lone pairs on sulfur? 2. In case of SO4 dinegative, how many lone pairs? Let me know fast. SO4 dinegative, how many lone pairs on sulfur? 0 lone pair on sulfur, right? NF3, 1 lone pair on nitrogen. NO2 negative, 1 lone pair on nitrogen. XCOF2, how many lone pairs on xenon? How many lone pairs on xenon? How many lone pairs on xenon, people, in case of XeOF2? I'm asking you. Oh, you want me to show it? See, XeOF2. See, first of all, let's make its random structure like this. This is XeO. This is, for example, 1 fluorine. This is, for example, 1 fluorine. First of all, how many valence electrons are there with xenon? There are 8 valence electrons. How many sigma bonds do we have? Sigma bonds is 1, 2, 3. 3 sigma bonds, right? How many lone pairs are there? How do we check it? See, we had total 8 valence electrons with xenon. Out of 8 valence electrons, it is using 1, 2, 3 and 4. Out of 8 valence electrons, it is using 4 valence electrons for bonding. So there will be 4 electrons left on xenon. 4 electrons left on xenon means 2 lone pairs, right? So 2 lone pairs with this xenon as well. Okay. Now, what I was supposed to check, find the number of molecules having 2 lone pairs, right? This having 2, this having 2, this having 2, this is having 2, and this is having 2, right? So if this is I3 negative, then how many? What is going to be the answer? 1, 2, 3, 4 and 5, right? Yes. If it is I2 positive, then if it was I3 positive, then if it was I3 positive, then I would have written this I3 positive like this for your convenience, I2 positive, right? How many valence electrons with this iodine? 7. There is a positive charge, 7 minus 1, 6, right? How many sigma bonds? 2 sigma bonds, right? How many lone pairs? 2 lone pairs, right? So there would have been 2 lone pairs on this iodine as well in case of I3 positive. If it was I3 positive, then 2 lone pairs. Then the answer would have been 6, right? If this is I3 negative, the answer will be 5, right? I'm sure it's clear to everyone. If this is I3 positive, then the answer would be 6, correct? Clear to everyone, people? Yes? Exactly, wonderful. So with this, your today's mock test is over, right? This was our 17th mock test, and people, 18th mock test for the JEE 2021 is going to be held on Monday at sharp 10:30 p.m., right? One thing I would like to share with you, right? You have got around 20 days, guys, for the JEE Mains preparation, right? See, the best and the last thing for you guys to shoot up your rank in JEE Mains is to get enrolled in the JEE 2021 crash course, which is not going to be held on YouTube. That is going to be held on the actual Vedantu platform by the teachers of your choice in your physics, chemistry, as well as mathematics. There are some highly experienced teachers who can complete your whole syllabus of your physics, chemistry, and mathematics in just 20 days, people, right? With everything done, It's going to be the best revision for you if you get enrolled in this JEE 2021 crash course, which is not there on YouTube, which is there on the actual Vedantu platform. Your whole syllabus for physics, chemistry, mathematics will be done in these 20 days, right? Trust me, people, it is the best and the last option for you guys to shoot up the JEE performance. Trust me on that when I say this, okay? Your whole syllabus gets completed in all the 3 subjects, which involves your assignments, test series, everything is included, right? Basically, you are getting trained by the teachers of your choice, okay? Personally, right? And how to get enrolled in this one? After a few minutes, I'll be letting you know how to get enrolled in this one. See, the date mentioned over here is wrong, right? On coming Monday, 9th of August, on coming Monday, day after tomorrow, one more batch for JEE 2021 crash course is starting. Please and please do get enrolled in this one for the ones whose preparation is not up to the mark, who just want to revise the things properly, right? Okay, please and please do get enrolled in it tomorrow or tonight itself, because the batch is starting on Monday, and it is going to be the last batch for the JEE 2021 crash course, right? It is going to be the last batch for the JEE 2021 crash course on the actual Vedantu platform. So do get enrolled, and it's completely affordable as well, right? Just for 5K if you use the coupon code as WSCC, right? Let me show you exactly how to get enrolled in this one. Let me show you exactly. See, guys, this is the video which you guys are currently watching. This is the video which you guys are currently watching, right? Yes. Okay, you just need to drag this video a little down, right? Just drag it a little down. Just click on this show more. After clicking on this show more, you'll be getting a lot of links. One link is for KVPY SX 2021 crash course, right? One link is for the KVPY SX 2021 crash course, correct? Where has it gone? Okay. One link is there for KVPY SX 2020 crash course. You can get this as well, just for 4K if you are using the coupon code, right? There is one more link which is for the JEE 2021 crash course. You need to click on this link for the JEE crash course. After clicking, you will see your physics, chemistry, and maths whole syllabus will be getting covered, right? Okay, and if you are using the coupon code as WSCC, you'll be getting some 60% off. And after the 60% off, you are just getting this crash course for 6K, not for 6K, sorry, for 5K. Okay, you need to click on this buy now. After clicking on this buy now, you need to enter your email or phone, whatever is there, on which you get the OTP and get enrolled. Please do get enrolled by tomorrow, because on Monday, that is going to be the last batch for JEE 2021 crash course, guys. Please and please do get enrolled for that. Why I'm telling you, why I'm stressing on this too much, because this is actually going to be highly beneficial for you, right? Okay, there are 2 links. One is for JEE crash course, one is for KVPY SX 2021 crash course, right? Both the ones are perfectly beneficial for you, right? Okay, there is one more link in the description. That is for the Telegram. Do click on this link as well. Get added to the Telegram group and stay updated about the classes, right? And the ones who have not liked the video yet, please and please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? So with this, people, I'll take a leave. It was nice meeting you, right? I'll see you guys day after tomorrow at the same time with the 18th mock test. Till then, you guys take care. Bye-bye. God bless you all and love you all. Yes, there'll be 60 mock tests for NEET Saravana. Yes. Bye, guys. Take care. Bye-bye.